All right, so what I want to do is quickly go over the exam too, and then we're going to look at the lab exercises 5 and 6 that's requested, right? Okay. So here it is, the bean jar class. The UML diagram, does anybody want to see that, the UML class diagram? Okay, I'll do that. I've already put the code that's been given in some files. This is beanjar.h, beanjar.cpp, main.cpp, test code, and then we compile the whole thing like that. So although you don't do this on the exam, obviously, but I thought I'd show how it works in practice. So let's go ahead and put the UML class diagram in a comment block. Oops. And that doesn't need to be a comment, so I'll do this. All right, so there's 3 sections. In the first section is the name of the class. In the second section are the member variables. And I'm going to look at the exam question, int max beans, int beans. They're both in the private section. Minus sign means private. We have max beans, which is an int. And we have beans, which is an int. So the data type follows a colon, which follows the name of the variable or the function returning that value. And then we have the member functions. There's the constructor, bean jar, and that takes max beans, which is an int, and it takes beans, which is an int. And then we have the getBeans function, which returns an int. It takes no argument. And then we have addBeans, which takes an integer argument, and returns a bool. So that should be public. It's a plus. And this is what is this? addBeans. And it takes the beans to add, which is an int. The whole thing returns a bool. And then we have removeBeans, which is the same as this. If you've just come in, please come down, and your exam paper is up there. Just look through the stack, all people who don't have an exam yet. So here's the UML class diagram. Unified modeling language. I should have actually used a different character here. That's a little easier to look at. Any questions on that? So the first problem, draw the UML class diagram. We've just seen that. The second problem is to implement the constructor. Now, for your answer here, all you needed to do is put these two lines in here. That would have been fine on the exam, but it's hard to see what I'm doing on the screen here. So I'm going to, oops, that's not going to work. I'm going to actually complete the implementation. Though on the exam, you didn't need to do this. Once again, this max beans is a variable that's called max beans. It lives, its life expectancy is just the scope of this function. So it comes into existence when the function runs, and when we return from the function, that memory is discarded. But that's different than, although it's the same name, there's another variable referred to here as max beans with the same name, but it's a different location in memory. It is not discarded when we return from any of the member functions. It's discarded when we return from main. Although that depends on how we create instances. So we need to distinguish between the member variable max beans, which is the variable that's in the object that we're creating, that we're initializing, and the function argument max beans. So we precede the member variable max beans with this arrow to distinguish between these two variables. And by the way, this needs to have this prefix needs to be added to that. So the compiler knows that we're implementing a function that's a member of the beanjar class. Provide an implementation of the getBeans function. Well, getBeans returns the number of beans in the bean jar, so the function will return an int. And it's in the beanjar class, and it's called getBeans. And it was declared as const. All we need to do is return the beans that are in the bean jar. You can go this beans, that's all right. But see, there's no function argument that's called beans, so there's no conflict with the name. So we could just use the member variable name directly without preceding it with this arrow. Provide an implementation of the addBeans function. AddBeans returns a bool. And the simple way to do it is just to do this arrow beans plus equals beans. But what we need to do is to test to see that we can do that the number of beans we're being asked to add doesn't cause the number to exceed the jar's capacity, which is max beans. So if we can do it like this, if this beans plus the beans to add is greater than the max beans, then we want to return false, because we can't do it. Otherwise, we can do the operation, add the beans in, and return true. Now, not all problems are like that, just this problem. So we explain that in this description of how the class works. The class provides functions to add beans, remove beans, and get the number of beans that are currently in the jar. The functions to add and remove beans return a Boolean value that indicates whether the operation succeeded or failed. When one of these functions fails, the number of beans in the jar will not have been changed. For example, if a bean jar has a capacity of 10 beans, and there are 9 beans currently in the jar, then add beans 2 will return false, and the number of beans in the jar will remain at 9. So there's the description of how the functions should work. They don't always work like this. What we're doing is simply implementing the functions as they're required by the documentation, by the specification. All right. Develop test code to test the add beans function. Well, the test code is in the main function. And once again, you didn't have to write this out, the using namespace and int main, that wasn't necessary. But this is what I wanted you to do, something like this. Create a bean jar, and I'll make it look like this, bean jar. You see the class name starts with an uppercase character, but my variable starts with a lowercase character. That's just a convention that a lot of people follow. I would say most follow that convention. So let's create the bean jar. We have we need to pass in 2 arguments to the bean jar. The first one is the max beans. Oops, this should be max beans, not max beans. Max beans and then beans. So the max beans would be, let's say we'll use the example that's given in the description of the problem. We have a bean jar that can hold 10 beans. We put 9 in it initially. That's a bean jar that has capacity 10 with 9 beans currently in it. And so the problem is to test the add beans function. So we use the assert macro. We assert that that the bean jar dot get beans equals 9. That should succeed. And let's try to add 2 beans. This should fail. That should return a false. And the same number of beans should exist in the jar, 9. Let's suppose we try to add 1 bean. That should succeed. And then the total beans in the jar should be its capacity of 10. So that would be a test. That's following the description of the problem pretty closely, so that's a safe test to do. So this is get beans, which is const. Let me see what the error is here. That should be get beans. What does that say? Out of line definition of get beans does not match any declaration in bean jar. Get beans.
Is it because in the test code you have bean jar with a B lowercase?
I think, it's here, right? Get beans.
the
Oh
one
yeah,
level two.
this should be. Oh, that looks all right. Get beans.
No, the bean jar?
Yeah.
Should the B be lowercase?
No, this should match this. Here, it should match. Let's see. Let me look at this class here. This is the bean jar. This is get beans, returns an int, const. And this is get beans here. Maybe I didn't save that.
It's, yeah.
You see a mistake there?
Yeah, to the left, to the left.
Thank you very much. There we go.
We should get like 5 extra credit points for that.
Return bean jar, line
You
17.
spelled return wrong. There.
All right, there we go. So that's working. Provide an implementation of the remove beans function. Let's do that one. So remove beans. This didn't work very well. These are the beans to remove. So here we want to see if the beans to remove, which is beans, is greater than the beans we have, because we can't remove more than we have. We can't remove more beans than we have in the jar. So we need to check to see if the beans that we need to remove is bigger than the beans in the jar. In that case, we return false. Otherwise, we remove those beans and return true. Provide an alternative implementation of the add beans function that sets the number of beans in the jar to its maximum when the added beans exceed the available capacity. The function should continue to return false in this case. And 8 is the same. Provide an alternative implementation of remove beans where the code now does its best effort to remove as close to the number of beans that are being requested, but it can't go into negative beans. It'll return false if it didn't remove all the beans requested. It returns true if it removes exactly the number of beans requested. So these are alternative implementations. So we could do something like as follows. Here, when we are asked to add the beans, if the beans are too many that we're being asked to add, that means we're going to fill the bean jar all the way up.
God bless you.
That means the number of beans in the jar equals its maximum. That's all you need to do, is just add that line in there. Everything else works the same way. And it's similar here. If we're being asked to remove more beans than we have, then we'll just remove until we get 0 beans. And then we return false to say that we couldn't remove all of the ones requested, but we did. Bring the bean jar down to 0. Any questions about the concepts? Okay. All right, that's the review. And now what I want to do is go to, is it lab 6 we're working on? Is that right? Okay. Let's take a look at lab 6. And we've done exercises 1 and 2 in class. And I have a request to look at exercises 5 and 6. Does that make sense to everybody? Let's see, that's 6 arrays.
You said essays.
5 is counting occurrences. All right, so we know we have to implement a function called count occurrences. And I'll just start with a stub just to get things ready. And let's just compile the stub. Doesn't work. We need the vector header. And non-void, this is a non-void function. So we need to return something. We'll return 0. So we want to compile without warning. There we go. So we've got our stub code ready here. Count the occurrences. Implement the function count occurrences whose declaration appears above. The first argument of the function is a vector v of integers, and the second argument is an integer k. The function returns the number of times k occurs in v. So let's declare an integer that counts the number of occurrences that we see. And so we'll call it the occurrences. Initialize it to 0. Is that how to spell occurrences?
No, you are.
Oh yeah, there we go. All right, so then we return the occurrences. We need to do some work in here. Let's do that in a minute. Did I ask for test code? No, I didn't. No test code here. By the way, this is a typical question I would give you on an exam. So you could try solving this first on paper, just sketching it out the way you think the solution should be. Now, when you do these problems on the exam, if you have little mistakes, that's not going to hurt you. The same kind of mistakes that that might keep you from compiling and running your program on an exam. So, in the exam context, it's a little bit more forgiving. But, like for instance, you don't need to declare this all over again. You just show me the implementation. You don't need to include the header files or have a using namespace std statement in there. Just show me the lines of code that implement the function. Now here, some of the problems, like in problem 4, I asked for test code. But in problem 5, I did not ask for test code. But it would be good to have test code anyway, so I'm going to show it. So let's create a vector of int called v, and let's push back some values onto it. Let's count the occurrences of 4. So it should be count occurrences v comma 4, and that should equal 3. So let's use an assert statement for that. So when we call count occurrences with v and 4 as the two arguments, the function should return a 3. So we'll check for 3. And if we're looking for minus 4, we should get 1. And if we're looking for 40, we should get 0. There's some test code. So it fails because we haven't implemented anything yet. Now let's go ahead and implement the function. So we need to scan across the vector, look at each item, and test to see, is this item a 4? I mean, is it a k? Is it equal to k? If it is, let's increment occurrences. We know we have to scan the whole vector, so a for loop is the best to use in this case, because we know exactly how many times we need to, we know how many times the loop needs to run. So for I, we start with I initialized to 0, and while I is less than v dot size, we'll increment I. So v dot size gives the number of elements in v. We want to be strictly less than v dot size because the numbering of the slots in v, the numbering of the positions or elements in v start at 0. So as soon as we hit the vector size, we can't use that as an index anymore because we're one past the last index. I want to test to see if does v dot I equal what? Well, we want it to, in our test code, we want to, if it equals 4, we're going to increment the number of occurrences and return that here. But for our problem, it's a function, so we're not using a specific number. We're using k here. K is being passed in. It's the value we need to look for. If we find it at I, then we'll increment the number of occurrences there. We'll increment occurrences, which is our count of the number of times k appears in V. There we go. So for the problem, you only need to write these 5 lines. 1, 2, 3, 4, 5. On the exam, you would write down these 5 lines. Okay? Unless I ask for something more. If I ask for test code, then you would need to produce this test code or something like this. All right, number 6, two-dimensional arrays.
Did you test it to make sure it's good?
Yeah, I did.
Oh.
Yeah, it's right there.
Gracias.
Does it, I was about to ask, like the assert count occurrences, does that matter or no?
Yeah,
Can you give me a second so I can take a picture of this?
it's on the video, so you can look at it.
Oh, he was
My
quick.
concern about that is that, like, you know, you're pushing numbers into the vector, which is why you have to.
No, we're not pushing anything in the, oh, down here.
Yeah,
Oh yeah, in the test code.
yeah, so, you know, what if you are trying to use this function for something else, so, you know, you're, instead of pushing every value into the vector, you have, My brain is not working. Like, what if you wanted to use that code, your function, in a different lab or in something else?
Well,
Would that work for
this
something
will
else?
only work if you have a vector of integers. If you have a vector
Yeah.
of double, this will not work.
Well, I know that. I'm not talking about the vector type. I'm
Yeah.
talking about, you're assigning the values by using the pushback.
Yeah.
That's just a build vector.
Yeah, so that's my question is like, can we take that code of our function
Yeah.
and use that in something else, and will it still work for a different vector?
Oh, yeah. Yeah, definitely. Yeah. This is just a particular example. And we could get the numbers into V in a different way.
Yeah, I did.
There's push front, for instance.
What's push front?
It puts it to the front of the
Puts
vector.
it on the front, yeah. So the order doesn't matter.
Saves you a lot of time.
What?
No member named push front. Push front. How do you put it? I don't think you have a push
Yeah, I
front.
don't think there is, that's why.
No. But you could do it like this. You can do it like, let's do this.
It's just a random
Let's look at another way to do this.
So there's no push front.
Let's create a vector with 3 positions in it.
That would help me.
And then V of 0 is set to 4. And V of 1 is set to -4. And V of 2 is set to 6. And now the occurrences, if we look for 4, we should get 1 occurrence.
Professor. Right, I'll ask you. That's great.
Yeah. There's an alternative implementation, but let me make sure that it actually runs. Yeah, there we go. See here, we're using a different constructor. We're not using the, well, what I showed you before was a no argument constructor. Here's a constructor that takes an int, which is the size of the vector, the initial size of the vector. So this will create a vector with 3 integers, initialized to 0. And then we just simply write into the 3 slots the values that we want. So it's another way of producing a vector of integers. And it's a different length and so on. So the function still works. Anything else? Oh, okay.
You're missing opening
Okay, 6 two-dimensional arrays. Implement the function is all zeros that uses a loop nested inside another loop to determine whether a two-dimensional array contains only zeros. A declaration of the function is shown above. The array passed into the function will have 50 rows and 100 columns. Now, notice, not asking for test code. The test code is a little complicated. We can do it. I'll show you some test code. So here's the function. So we have a vector. And this is not all zeros. It's a single dimension. Oh, that's a two-dimensional vector. So is all zeros. We pass in A. This is a single dimensional vector. Let's make this a two-dimensional vector. let's give it 2 rows of 4 columns. So you can do it like this. Here's the first row. Here's the second row. And here's the closing brace. So here's the syntax that I believe works to create a 2-dimensional array. Well, we need to adjust this. Actually, I'm not sure that that works. Hold on, don't write that down yet. I cannot, how do I do a 2-dimensional array?
I just create a loop.
How do you declare a 2-dimensional array?
I think you can not initialize it
You can't do it.
unless you do a loop.
You have to say, I think, what the sizes are of the of each part.
Is that going to work?
There's 2 brackets, 2 sets.
Oh, I got that wrong. Thank
Yeah.
you.
Okay.
Oh, now it's just, it has to be 50 by 100. Yeah, we need a loop.
Yeah.
So if we had it like this, 2 by 4, this would work. It does. Should fail. Oh, just pass. Returns true. Oh, well. Should fail. There we go. That'll fail. So, but we need to do 50 by 100. So you're right. We need a loop. See, the arrays are a lot. They're less flexible than vectors. So with a vector, we don't have to worry about the size, the dimension. We can have a vector of vectors also. That would be like a 2-dimensional vector. But here, arrays are fixed in size. And so when you pass an array into a function, it has to agree exactly in its dimensions. So if we want test code for this, we'll need to create an array that's 50 by 100. What's that? That's 50 by 100. And to create the test code, we'll need to, well, this should be, we can run this actually. But the array is uninitialized, so we don't know what's in the array. Once again, for this problem, it didn't ask for test code. I'm just showing you how to do it. So we'll let I range from 0 to 50. And then we'll let j range from 0 to 100. And we'll store into A at position ij a 0. Close this loop, close that loop. So it should be all zeros. So that should work. And if we did something like this, A of 23, 43, we set that to, a -2, then the function should determine that the array is not all zeros. So the function should return false in that case. We're just using the same array that we just built up. Once again, we're using a stub here, so we really haven't gotten to the meat of the problem yet. We're just looking at the test code. And the test code is probably more complicated, or it's the same complexity as the function itself. I'm just going to copy that stuff so I don't have to redo it. Here we're going to range. I will range between 50, 0 and 50. J ranges from 0 to 100. And then we have a test. If the value at ij is not a 0, then the two-dimensional array is not all 0. So we can return false in that moment. Otherwise, if we pass through those nested loops without finding a non-zero, then we return true. It must be all zeros. All test passed. There we go. So once again, for the problem, you only need these lines here. Oh, here. Actually, you should use tests. Oh, that's for 1, I see. 1, I'm just asking, these are exercises. These are, you'll need to have some kind of test code. You'll need to write test code for this. I probably omitted that by accident. So you should add test code. I may change the exercise and state that you need test code for these. But these are questions that I took from an exam that I gave in the past. And so I started to ask students, at some point in the past, I started to ask students to solve problems that, for the assignments that resemble what you'll see in the exams. So in the exam, I'm not going to ask you to write out all the test code, the int main and the include headers, all that. I'm not going to ask that. I just want the implementation for the function I'm asking for here. But for the assignment, you should go through this exercise of defining the function, implementing it, and then providing some test code for it. Okay. Any other questions? It's 12:50, so we have 25 minutes.
Turns out there is a way to initialize them all to 0.
How to initialize them all to 0?
Yeah, set equal to curly braces, and then the curly braces just put 0.
Just put a bunch of zeros?
No, just put equal to.
Let me try that.
No, right there, right after, yeah.
Right here, right?
Yeah, equal to, and then curly braces, 0, 1.
That'll do it?
It should be.
Let's try it. Did you look this up somewhere?
I did, yeah.
Well, that's good.
It only works for 0.
It only works for 0?
Yeah.
Yeah,
Oh,
I did that when I was testing.
only works for 0.
Yeah.
Well, that's interesting to know. Okay. Not sure I would trust that. Could be that memory just happens to be set to 0 when this
I
runs.
see outed to
Yeah.
see.
Well, I'm sure it's all zeros.
Yeah.
And because we've done the test here, I mean, we've done it here. But will it always be all zeros for all programs, compiled and run on all machines in different situations? It could be that the memory that is in the array is just conveniently 0. But if this is part of the standard, the C++ language standard, and compiler writers are implementing this part of the standard, then we can rely on it. But I think this would be part of a new. See, I wouldn't trust this across all compilers. You might get an old compiler that doesn't handle this correctly. Of course, it would probably generate an error, but I don't know. Anything else? Do you want to look at any of these other? Oh, also, I want.
Insert,
Huh?
the insert function.
Insert function? Okay. Another thing is the deadlines. Does the deadlines make sense? So November 7. Oh, so we missed that already. Binary search, we need to get to that. And then sorting, and then exam 3, November 24.
We can push exam 3 if you want.
Plenty, with plenty of time till we hit exam 3.
Or we can push exam 3 to Wednesday if you want to just do like a review on that Monday. Because I mean, it is the weekend, and then
Oh, here? Let's see. Yeah, when we get closer to it. It's still
just heads
2
up.
weeks away. Yeah. Sure, I'll take recommendations on that.
That way,
We
we
can
have
take
the
a vote.
midterm right before we have break.
You want this before break, not after break.
Yeah, right before break. So
When is break?
So which?
wait, what's the 24th? That's a Monday.
That's a Monday. The 26th is a Wednesday.
And we
And
have
then we
class.
have break right after.
Yeah, we have class on the 26th, right? So
Yeah.
How long is the break?
Thursday to Monday.
Yeah, Thursday to Monday. That's it.
Well,
That's the
technically it's
27th.
Sunday because we have school Monday.
Let me think about it. I want to get sorting. Is sorting covered? Do you have enough time? Exam 3. So, yeah, I think we can probably do that.
If you wanted to skip lab 9 in that chapter, I will be willing to forego that so we can make sure to cover arrays, vectors, sorting, application. I mean, we can just do that next year or something.
All right, let me think about that. The exam time. Yeah. Talk to me later about the exam schedule during that. What's the other? It was the insert function that you wanted to look at? Which number is that? Oh, here. Exercise 4, vector insertion. Yeah, this is a good one to look at. Okay. So suppose a vector v contains a sequence of integers ordered from lowest to highest. For example, v might contain the values 3, 6, 7, and 12. I'm not going to read anymore. I'm going to stop and create a test case just for that right now. So 3, 6, 7, and 12. Three, 6, 7, and 12. I'll do it like this. Three, 6, 7, and 12. Here's a vector with 4 integers in increasing order. Write a function called insert that takes this vector v as a first argument and an integer k as a second argument. The function inserts k into the vector so that it preserves the order of elements. For example, if v were 3, 6, 7, and 12 and k were 8, then after calling the function, v would be 3, 6, 7, 8, 12. In your implementation of insert, do not use the insert function of the vector class, v.insert. So there's already an insert function in there. But we're going to practice reinventing the wheel. Okay? Rather than using a pre-supplied function, we're going to implement it ourselves. Write test code to thoroughly test the function. All right, so let's
I don't know if you can.
let's check this. So v of 0, let's call insert v and 8. So we want to insert 8 into v. So when we're done, the first element will be 3. The second will be 6. Third will be 7. The fourth will be 8. And 12 gets pushed into the 5th position, which is position 4.
Does it work since you still have the count occurrences on top?
No, it won't work. It won't compile. That's right. So this will be, what is it called? Insert. So to insert the vector vk, look at that. So we'll do something here. So this should fail, right? By the way, it won't even compile. Why won't this compile?
Because you're not finished.
Well, it'll compile now. It'll compile now, but yeah, let me leave that in there so we'll see that fail. That's right, it's ex4. Insert needs to return a value.
Does it need to return value?
Well, we'd have to declare it as not returning anything. So we show it as returning void. All right, so that compiles. Well, we're going to have trouble. That's a mystery. Why? This will ultimately fail to compile when we get to work here. All right, so what we need to do is we need to make the vector 1 larger to hold another element. So I'm going to do it like this. I'll push back anything. I'm going to push back a 0. And then what we're going to do is push numbers back until we find the spot where we can insert k. So we'll start at the end of the vector. We'll do it like this. Should I use a for loop or a while loop? Huh? For loop? So let's start at the very end. V dot size minus 1. That's the last valid index. And I has to be greater than or equal to 0, and we may change that. Yeah, then we decrement I. So if V of I is greater than K, then we need to move what's in V of I to V of I plus 1. Am I doing this right? Yeah. But actually, we can't start here. We'd have to start here, wouldn't we?
What?
It's the last one plus 1, right?
Huh?
Minus 1.
It's plus 1.
Was it plus 1?
No, that's right.
No, it's
No, I'm
minus.
just saying because you're going to be using plus 1.
Yeah.
Why?
What? Can you explain that, please?
Yeah, let's look at it.
Because he's pushing a 0 into the last spot, so there's no point in checking the last spot. You want to check the next one.
Also, I can't, if K Actually, I should push a 0. This isn't right either.
You should push K.
Yeah. Maybe.
Yeah, I pushed K, even though you override.
Yeah,
it,
in the past, you can swap it. Actually, what we can do is,
That's why I use
you can
it's
just
more
swap.
efficient not to swap, but let's swap. Let's push back K. All right, let's look at what we're doing here with an example.
created a temporary vector.
3, 6, 7, and 12. And then we start with I equal to, I'm sorry, we don't start with that. We push back K, which is 8. And we set, we can either start with I here or start with I there. It doesn't really matter. Do you want to start with I at the end or I one before the end? Any preferences?
I can.
End?
Use J.
Is it J?
No, just go ahead a variable.
So we push back the K, and then we're going to start at position v dot size minus 1. So I would be sort of pointing to the K that we just pushed back onto the vector. And we want to go until a while. I'm not sure yet what we need to do there. Maybe this is good enough. I don't know. All right, so when we look at v of I, so that would be 8 in this case. Actually, that doesn't look good to me. We're going to use swap, right?
Are you sure constant should be right there?
No, that was the secret. That was the secret you needed to discover. That would make it fail to compile. Good job. All right, so
Visual Basic says you're welcome.
yeah, it's I got to tell you, it's hard to explain it as I'm working this out up here. It's hard to explain this because I don't have the solution in my head, right? So I'm trying to explain something that I don't even know. Yeah,
Creating as we go along.
yeah, huh?
When I did this, I did for VI is less than VI minus 1.
Yeah,
Instead of random K.
you could do it that way. There's so many different ways of doing it.
It's 3 different conditions for each.
Yeah, so we could do swap. You want to do using swap? Oh, we'll try swap, okay. I think it's more efficient without swap, but we can use swap.
What's swap?
Swap exchanges the two values.
Oh, okay.
So if v of I is less than v of I minus 1, then we want to swap v of I
I think that works.
and v of I minus 1. Yeah,
Swap only works for vectors.
Yeah.
really?
You
Swap only works for vectors. You have
Yeah,
to
you have to make a copy of the vector,
Yeah.
push your K into it, find the K into the proper place, then swap your vector W with your vector V. That's
swap
how I
only and
first
swap.
learned it.
I don't believe that. I don't believe that.
It doesn't work for individual elements.
This doesn't work?
Not for
Google
individual.
Not for
challenge.
individual ones.
Yeah.
He and I, whatever the students in the front, we found the same thing.
All right. So we'll do it like this.
I created a temporary vector. So
But the thing is, it's always K, so we don't even need a swap, really. We don't need swap because we know it's K. We know it's K.
Why y'all swapping things?
So it's just V of I gets V of I minus 1. And
Yeah.
this is K. We don't even need this. Just that's K. All right. And here we could, yeah, I guess we could put that like that. We don't even need, we could use this as 0 again. This doesn't matter. Just to make my point, I'll put a 0 in there. All right, so we're going to look, we'll set I here. And then what we do is look here. So we start with I in that position, and we look at what's in position I minus 1. So we'll see the 12. But I minus 1 is where the 12 is. And so we look at that value. Is k less than 12? Is 8 less than 12? It is. So what we need to do is store into v of I the value that's at I minus 1. So we're going to move the 12 into this last slot. So now it doesn't matter what we initialize the vector to. What happens if k, so we're going to figure out what to do there. Right? So if we're looking at v of I minus 1 and we see that it's bigger than our k, we're going to have to move what's there back. So we're moving things back. And now look, so we've just run this line here. And we're in this loop. So now we need to decrement I. So when we decrement I, it's going to look like this. I is now pointing to that slot. So then when we compare k with v of I minus 1, well, v of I minus 1 is now what? 7. Because I is here. This is I. And I minus 1 is there, 7. So is k less than what's at v minus 1? Well, in our case, in our sample code, it's false, because k is 8. K is 8, and k is not less than 7. And so we need to write the value k into the position I. And by the way, we're done. After we do that.
So then what are we returning?
Void. We don't return anything.
Okay.
Now the problem is we need a new example to make sure that we got the. Let's start with a simple example. There's 4 and 7, and what we want to push is k equals of 1. We want to make sure that that works correctly. So I need to test the boundary case. So this is where the value we're adding should slide all the way to the very front. And then the other example we should test is that when k is, say, 30, and the vector is 6 and 9, something like that. So this is the other boundary case where the value stays at the end of the vector. This is the boundary case where the value is pushed up into the front of the vector, and this is the normal case where the value is inserted somewhere inside the vector. So we want to test these cases. Before we do that, we can test if the code we've written so far is correct. Looks good. So let's do this. Let's create, what did I have up there? 4 and 7, and insert a 1. We'll call this U, and it has 2 elements, 4 and 7, and we want to insert a 1. And I'm going to bring these together so we see that that's one test here. That's one test. Here's another test. So this should be, when that finishes running, this should be 1, 4, and 7. So this one should, I don't know if this one fails. I don't want to even run it because we should check it with by analyzing the function. What happens when, in this case, where the vector is 4 and 7, we're inserting 1? So let's see. We'll start here. I've got to finish this quickly now. Here's the I. So K is, I'm sorry, not this one. K is 1. And I is initialized to 1. And then we look at v of 1 minus 1, which is v of 0. Sorry, no, we have to add, we have to push this 0. Yeah, I'm running out of time, so it's going fast here. So we push this 0, and then we, this is, I is now 2, v of 2 minus 1 is v of 1, which is 7. K is less than that, so we move this. So we get the following. I'll be done in 1 second here. This becomes a 7. And then we decrement I. And then we get the same thing again. That 4 gets moved into this slot. And we decrement I again. Now I is 0. So I is greater than 0 is false. And so we finish the loop without doing anything. But what we need to do in that case, and I'm running out of time, is the algorithm looks terrible. So v of 0 would then get, okay. I'm running out of time. We can't polish it right now, but that works. But that's horrible code. We can make it look a lot nicer than that. All right, let's resume next time. That's it for today.